right, good evening, everyone. I think we're ready to get started, if everyone can find a seat. Thanks so much for coming. My name is Jessica Hellman. I'm an Associate Professor of Biological Sciences here at Notre Dame, and it is a great pleasure to welcome you all to the first annual Sustainability Lecture at the University of Notre Dame. And this is a new lecture series featuring prominent thinkers and doers in sustainability, and we designed this lecture series to complement our new minor in sustainability. We have many funders to thank for tonight's inaugural lecture, and I want to name them briefly. That would be the College of Science, the Institute for Scholarship in the Liberal Arts, and the College of Arts and Letters, the Institute for Advanced Study, the Office of Sustainability, the Center for Sustainable Energy, the Department of Anthropology, and Indiana University South Bend's Center for a Sustainable Future. And we are extremely fortunate to have Dr. Wes Jackson as our first sustainability lecturer. Dr. Jackson was born and raised in Kansas. He attended undergraduate and graduate school in the state before earning a PhD in genetics at the University of North Carolina. Dr. Jackson then joined the faculty ranks at 2 universities before resigning a full professor position in 1976. And I can tell you that as a faculty member, I mean, imagine that, quitting a tenured full professor position at a teaching and research university. But Dr. Jackson had a grand idea, actually several grand ideas, and he had a vision for doing something interesting and important back in Kansas. So in 1976, Dr. Jackson started the Land Institute, a not-for-profit organization dedicated to creating an agricultural system with the ecological stability of the prairie and high grain yields. Initially, the Institute was established on just a few acres of land, but today it occupies about 600 acres. The Land Institute has successfully domesticated native perennial grasses in their search for alternatives to the world's major grain species. And they do this in polyculture. This means they grow multiple species together at the same time in order to maintain healthy soils and to minimize chemical inputs. Now, Dr. Jackson, not surprisingly, has been widely recognized for his work with the Land Institute, where he still serves as president of the organization. As an example, 2 examples, Dr. Jackson was named a Pew Conservation Scholar in 1990 and a MacArthur Fellowship recipient, the so-called Genius Award, in 1992. And more recently, Smithsonian Magazine named him among 35 individuals who make a difference. Dr. Jackson's most recent book was published in 2010 and is titled Consulting the Genius of the Place, an ecological approach to a new agriculture. So please help me warmly welcome Dr. Wes Jackson.
Thank you.
Give me a nod if you need me, okay?
Okay, sure. Well, thank you, Jessica. And it's great to be here at this absolutely beautiful university. We Methodists don't do things like this. We mostly sit around and hurt, I think. But there's something about this place that make you almost want to forget the Reformation. I mean, what were we doing anyway? What did we have on our mind? You know. Well, anyway, it's good to be here, and it's good to be seen. I'm glad to still be seen. People say it's good to see me, and I tell them I'm glad to be seen. I see some of my friends dying off, and a kind of a great sadness overcomes a person when they see their peers dropping off. I've got a lecture that is kind of a different lecture prepared for you. My kids used to say something like, "Dad, would you explain that and maybe this time not go all the way back to the Big Bang? Maybe start somewhere this side of the Big Bang." And, you know, we know there are other reasons why that stoplight is there. and you don't have to go back to the Big Bang to explain why. So I'm sort of warning you that maybe I'll be going back too far, but one thing I know is that I'm going to get heated up, and after all, the Spirit of the Lord may come upon me, and the glory of the Lord may shine around about me, and I may make you all sore and afraid before this is over with. I guess that's not funny to you people, is it? It wouldn't be funny to my Methodist friends, but I thought I could get away with it with you folks. I'm going to start with a slide that my wife told me to take out. And I tell her that I've got to have this slide and that people that are serious can handle it. Now, I don't know. We've got two of these. Oops. How we doing? You see where we are? We're going to go through this kind of slowly because it sets the stage for everything. This is all this side of the Big Bang. We start at 3.45 billion years ago. And that's because essentially, all life can be traced back to that time. And it's carbon-based. And as a consequence of that, there is among life forms what I call the 3.45 billion year old imperative. We go after energy-rich carbon. If there's bacteria on a petri dish with sugar, the bacteria just grow until they hit the end. Or if it's Drosophila flies in a flask with mashed up bananas and some yeast, they just grow. And if you look at those curves, and given, say, that humans have managed, probably starting with fire, to deal with the parasites, mostly worms. I mean, we cook the meat and you get rid of the worms. And also with fire, we're able to keep the predators away. And then along comes penicillin, and you look at the curves, and now here we are at 7 billion, headed to 9. And those curves for the petri dish, the Drosophila flies, for humans, deer without predators, you got the story. So that's what we do. I'm 75, and in my lifetime, almost 99% of all the oil ever burned has been burned. My 10-year-old granddaughter has lived through a quarter of all the oil ever burned. 22-year-old graduating, this was 2 or 3 years ago, has lived through 54% of all the oil ever burned. So that's what we do, and that's what I call the 3.45 billion year imperative. Well, about 10,000 years ago, we got into the first pool of carbon and started using it at levels or rates that were beyond the natural renewability level, and that was getting the young pulverized coal of the soil. That was the beginning of agriculture. At the eastern end of the Mediterranean, the ice is retreating, it's drying out, and there is where the beginning of the first group of revolutionaries, the greatest revolutionaries to ever live, that started the agricultural revolution. They got a plant out of probably the Zagros Mountains of western Iran, the wheat plant. It might even have been only one plant, but it is that plant that there is the first. And it wasn't too many millennia later that it was rice in the Orient, and then, of course, in Middle America, corn. And before this revolution was over, essentially all of our crops and livestock had been entered onto the human inventory. So the humankind's role in changing the face of the earth has been the most dramatic as a consequence of agriculture. Now, there's something particularly important about that, and that is that we now depend on 70% of our calories from grains. Humans are primarily grass seed eaters, and secondarily legume seed eaters. And oh yeah, there are a few oil seed crops in there, but mostly grasses and legumes. And in the oil seed crops, sunflower family and some others. What's interesting is that they're all annuals. They come up from seed. And they come up from seed, and their seeds are big. And they have to be big in order to come up through, get their leaves to spread, capture sunlight, and then comes death, harvest, they'll drop to the ground, whatever. So for us to exploit those seeds, to get those annuals, we have to create a habitat similar to the kind of habitat where those annual seeds would be, a disturbed area. That's where they go, as disturbed areas. And so we till. And in the tilling, a very important psychological and philosophical reality comes to Homo sapiens, and that is nature's to be subdued or ignored if we're to eat. And that's 70% of our calories now, growing on about 70% of our ag acreage. So I call that the problem of agriculture. But beyond that, what we were doing is getting the young pulverized coal of the soil, as I mentioned, and with the opening of this continent, we probably sent the soils from 6% carbon to 3% carbon. There's good reason to believe that was about the carbon level of the wild. So about 5,000 years ago, we started using forests to smelt the ore for the Bronze Age and the Iron Age. And if you read the Epic of Gilgamesh about Enkidu, the wild man that would run with the gazelles and drink with them at the water holes, and was seduced by a young priestess from the city, and from him falling in love with her, he was no longer able to run with the gazelles. But then he joined up with Gilgamesh, and they set out to find the giant that protected the forest, the cedar forests. Well, they found the giant, they killed him, and then soon the woodcutters come to harvest the forest. So there's that mythology. We have probably always been myth makers to try to understand our relationship to the universe, or our understanding. Well, in 1750, then we started using coal for power, and that's, of course, the beginning of the Industrial Revolution. And we can see what some of the consequences have been. Read Wordsworth's Michael. Represents probably the first time a representation of the boy not coming home. We see this in our literature, what the consequences of that industrial revolution have been in taking away our connectedness to the land. And then 1859 is Drake's oil well in western Pennsylvania, and right after that we started using natural gas also for power. Natural gas goes all the way back to, it goes back to the oracle at Delphi. I mean, that eternal flame back there, and these oracles, you know, they have a way of speaking with the characteristic ambiguity. I feel a digression coming on. Let's see if it passes. When Croesus went to make war against the Persians, he consulted the oracle at Delphi, and the oracle said, if you make war against the Persians, a great kingdom will fall. And so he was heartened by this. He made war against the Persians, a great kingdom fell, his. The prophetic tradition is better. It's better to stick with the prophetic. I think it has something to do with natural gas as the source of the flame for the oracle, but I could be wrong on that. All right, and then, so there are those 5 pools. The digression is over. I give myself 1. Now, that's the way we've solved problems, is to go after non-renewable supplies of energy using the 3.45 billion year old imperative. Over under the column for land, that's another way. 1492, Columbus sailed the ocean blue, and in 1803 is the Louisiana Purchase, the safety valve for an overcrowded Europe. And then 1862, and we'll talk about the implications of that, 1862 is the Homestead Act. Why 1862? Well, the war between the states started in 1861, and finally the South wasn't there to vote against a Homestead Act because the South knew that if it was open up, that it would be a spread of the Free State. So, but that's a way we've solved problems. And we'll say more about this chart. You'll see it again. So there's one summary so far. And there's another summary so far. I want to say a little bit more about 1859. That is, in addition to Drake's oil well, it's a little over 100 years after the Industrial Revolution begins. And I was mentioning to a group today that it was only 10 or 20 years after the beginning of the Industrial Revolution that in the tea houses of London they began to talk about the end of slavery. If you got power, you don't need the slave. Well, we're slower at getting the Industrial Revolution underway here. So in 1859, John Brown was hanged at Harper's Ferry. John Brown was beginning to get enough purchase from the industrial North that maybe slavery was a bad idea. Unfortunately, the agrarian South didn't have much coal. They had a slave society. So virtue is easier to have if you have a lot of energy. You can solve problems. You can begin to think about the end of slavery. So John Brown, he wore a shot, really. He took Harper's Ferry. They end up hanging him in December. The third thing about 1859 is Darwin's Origin of Species. hits the London bookstores. And I contend that without soil carbon, forest carbon, and coal, we wouldn't have had Darwin. The slack made available by the British Empire to send a naturalist around the world. The slack that allowed him to stay in his country home at Down and observe his specimens and write letters. That's slack. That wouldn't have happened too many years before. Now, we did have soil carbon and forest carbon that sponsored, well, let's tick them off. Francis Bacon, René Descartes, the architects of the scientific revolution. Francis Bacon did have the slack to write a treatment, actually write a novel called New Atlantis. And if you read New Atlantis, there's the prescription for the recipe for the modern scientific laboratory. And then there's Galileo. And Galileo dies in 1642, same year Newton is born. So those guys were running on the two pools, the first two pools. And then the Royal Society picks up on Bacon's New Atlantis in essentially defining the outline for the Royal Society. So here, all of this, the product of, well, the assistance that's been granted. So that Louisiana Purchase was a chunk. That was a chunk. When we came across the continent, well, this is not a digression, I promise you. Dan Luton at Berkeley, a friend of mine, we were coming back from San Francisco over to Berkeley. He was a faculty member at Berkeley. And we had attended a meeting for Friends of the Earth, wringing our hands. And Dan said, he later published this, he said, you know, Wes, here's the problem. We came as a poor people to a seemingly empty land that was rich in resources. And we built our institutions for that perception of reality. Our political institutions, our economic institutions, our educational institutions are all predicated on poor people in an empty land that's rich. Well, now we've become rich people in an increasingly poor land that's filling up. And those institutions don't hold. We patch them up. We give them a lick and a promise, but they don't hold. So there's the safety valve. And Lewis and Clark make the trip. There's this expansion solving problems with land, and we're land animals, primarily. Oh yeah, we eat shellfish and other things, but mostly we're on the land. We're not swimming around to get our food. So, May of 1862 was the Homestead Act. Anybody that could spend 10 years, pay a small fee, could settle on 160 acres and claim it his or hers. Well, it's interesting that 3 months later comes Morrill, that Yankee who introduces the Morrill Act that establishes the land-grant college system. Every state is going to have a land-grant college, and it's for the democratization of knowledge and then the opportunity for that knowledge to be spread throughout our newly acquired territory, or where our settlers are going now. Well, just having the college isn't enough. By golly, we need experimentation. We are the children of the Enlightenment. So, what has been our history? Well, Christianity says that there is God, and it also says that there is the spiritual, and there is knowledge, and then there is also the experiential, the root of experiment. And so we put in the experiment stations with the Hatch Act. So, well, that's not good enough. We've got the college, we got the experiment station, but how are you going to get it out there to the farmer? So we put in the extension service, and that is the SmithLieber Act. Now look, we're on our way, gang. We're children of the Enlightenment. We have land. We're using, you're using our resources in responsible ways to make life better. All the things that were promised by Francis Bacon and Descartes. Descartes said this, it's in his Discourse on Method. The more I sought to inform myself, the more I realized how ignorant I was. But as Wendell Berry said, rather than regard that as an apt description of the human condition and the very proper result of a good education, Descartes thought our ignorance correctable. And yet we all know we're billions of times more ignorant than knowledgeable, and always will be. So that's what caused us to sponsor a conference called Toward an Ignorance-Based Worldview, saying let's go with our long suit. Let's have an ignorance-based worldview rather than a knowledge is adequate worldview. And so you can now read this volume that came out of that conference called The Virtues of Ignorance. We had a banner across the street, welcome ignoramuses. Well, we're totally serious about that, and I can tell you how we came to that idea. I'm going to have some water. I can see if there's water here, all I need is hey, I use my hand. Maybe this is gas. It says industrial water, do not drink. Okay. Well, this is sort of a quasi-digression. Don't count it. But Wendell Berry had been reading Hans Jenny's book, The Soil Resource. Hans Jenny was a great soil scientist at Berkeley. And he quoted Jenny, who said, the rain message, thank you. Oh, now this will work. Yeah. Does it have vodka in it like I asked? Okay. The rain message enters the forest canopy, and through crown drip, leaf drip, stem flow, the rain message is transmitted downward to the forest floor, where it leaves as it entered at random. End quote. And then Wendell said, is Professor Yenny's use of the word random a verifiable observation or a limit of perception? He says, I suspect that the honest answer is it's a limit of perception. Therefore, he should have said, the rain message comes from mystery through pattern back to mystery. That to assign the language of science to the unknown is to appropriate the unknown and do what the Greeks warned us against. It's an exercise of hubris. So it is in that spirit then that we convene this conference on ignorance, which then has helped us appreciate some of the problems that have come out of the land grant system. So you just hold that on a back burner. So World War II is over. And finally, after World War I, a depression, World War II, we're able to take advantage of the most important invention of the 20th century, which happened in 1909, when two Germans, Fritz Haber and Karl Bosch, learned how to take atmospheric nitrogen and turn it into ammonia. That, as you know, this is 78% of the atmosphere is oxygen, 21% nitrogen, but it's one of the strongest bonds in nature. Oh, it's the other way around, isn't it? One of the strongest bonds in nature. It's very hard to break. Vaclav Smil's book on nitrogen, he contends that without Haber-Bosch, 40% of humanity wouldn't be here today. In other words, the natural gas that stands behind running Haber-Bosch is responsible for 40% of the standing crop of Homo sapien. So there it took off, and it's another way that we've gone after that energy-rich carbon is in order to get the nitrogen, using the natural gas. So there you can see both the nitrogen, water consumption goes up, phosphorus goes up somewhat, and there's the story right there in these anhydrous ammonia tanks. Well, 1948 is another takeoff, something else took off, and that's the pesticide industry. The introduction of chemicals that our tissues have no evolutionary experience with are put on our fields in order to control or to manage the insects, pathogens. And there you see Silent Spring is 1962, Rachel Carson. Since then, the pesticide industry has doubled and doubled again. And then here is the diesel fuel. So there it is. Now, look at the size of the container that's holding those calories of fossil carbon. Now, Norman Rockwell's county agent took place, that painting happened right here in Indiana. And that's 1948, as you can see. But let's look at that and think about to what extent the Morrill Act, the land-grant college, the experiment station, and extension are at work. That's an extension agent there in the brown uniform. The dutiful 4-H girl with her record book is listening and paying attention as he measures the girth of a Guernsey heifer. There's brother with the poultry project. There's sis with the sewing project. Mom is looking on, grandpa's interested, the horse is interested, dad's back in the shadows. The dog's even pleased with this scene. I mean, everything is focused. What do you see in that painting? I think what Rockwell was painting is what got writ large. Well, expertise and youth are central. Tradition and experience are peripheral. It's a new day. It's a new world. He was painting what was at once, I think this is a watershed moment. He was painting what was the culmination of those three acts, all made possible due to the expansion of land and some modicum of non-renewable carbon. Well, what happened starting about that time? Farm sales. That's an auction. The loft of that barn is the fuel tank for the farm. The hay would be there, and that is not very dense carbon. We don't like to muck around with non-dense carbon. We want it nice and dense. And the older, the better. Well, it could be 1 billion or 2 billion, doesn't matter. But, but there's the fuel tank. Below where the straw is where the manure and the urine got collected, and the urine representing the nitrogen. So your barn is a fuel nitrogen management system, part of a fuel nitrogen management system. Well, what happens if you have a fuel tank with fuel oil in it, and you have an anhydrous ammonia tank with ammonia in it? Well, you prop the barn up, but they go down. And look around rural America. The only reason barns exist in good shape is out of nostalgia. You get another kind of something. So this is a cultural artifact that is no longer needed in a highly dense energy world. Now, this comes out of H.T. Odum's Environment, Power, and Society. This is a generalized scheme showing all these little whiskers going off. That's where photosynthesis takes place, capturing sunlight. And then the concentrators is where respiration occurs. Now, here is an example where you have a slide that's 3 inches long, a microscope slide. All those little circles, those are diatoms or algae that capture sunlight. And then there are the tube animals that are the concentrators. Or looking down on a tropical rainforest, here you have the canopy that is capturing the sunlight, but you have the trunks and limbs that are the concentrators. And then looking down on Kansas, back in the 1930s, you have the fields that are capturing the sunlight, and then you have the farmsteads and the small towns that are the concentrators. The farmstead capturing the photosynthate. You reduce those to a common scale, and the radial arms going off from the concentrator to the photosynthesizer is about the same. So, what happens? You introduce fossil fuels, and you get rid of farmsteads. You change that relationship. I think there's a general law. High energy destroys information of the cultural and biological variety. So the war on the rainforest and the war on small towns and rural communities is the same war. And it comes as the consequence of the imperative of highly dense energy. We call it a failure of public policy. I can tell you, friends, I don't go to Washington to try to deal with the 5-year farm bills because I know how they're going to come out. They come out the same with some little tweaks. They'll throw a bone to the sustainable ag people. And we'll go running after it, you know, and salivate and lick our chops and count it as a victory. You know what percent of the ag landscape of the United States is for organic agriculture? It's less than 1%. After all these years of a sustainable ag movement. It, I think, gets back to that imperative that we can't say no. Now, there's more to it than that, but that's part of it. So, what happens? The cultural capacity is now mostly gone. I found out the name of that county agent, and I found out the town, and I made a phone call to that town and asked for anybody by the name of Ripley. That happened to be the name of the county agent here in Indiana. I got a Ripley on the phone. I think he was maybe the real estate person. I said, you know that guy in that painting? You know the painting? Oh, yeah, we know the painting. Well, you know the man? Yeah, he was an uncle. I said, what about the girls? Oh, yeah, I know them too. Well, can you give me their names? Yeah, he gave me their names. I called one of them up. I called up Sharon on the left. And I asked Sharon questions. And she was, you know, forthcoming, and so was the county agent's relative. Well, is there any of you, your family, on the farm? No. I'd asked the county agent, what about each one? He said, well, the brother died during the 80s. He was on the farm. But none of those people are on the farm, and none of their kids, they've just rented out. So what about that cultural capacity where you know how to sew, where you learn about poetry, or poultry? It's the same. Where you, sorry you poets, where you learn about the girth of a Guernsey heifer, where you learn about keeping records in a book. Just nostalgia? Well, what have we substituted it with? This is how we use the opposable thumb that we got in the forest. So we say, well, times are different now, things change. I mean, technology's coming around, humans are technological creatures, and you know, you got to stay up with the times, and that's mature judgment. But we've sensed some kind of loss. And I think that cultural capacity we're going to wish we've had when we transition from this fossil fuel interlude. And it's worth considering that it's been the use of energy that's been the destroyer. So to think, well, we will come up with something, we better then be thinking about, do we have the ability to handle the energy wisely? Well, here's a cornfield. This is in Iowa. And this is a gift of the gods. We've gone to over 200 bushels per acre now. We have a bushels and acres attitude, and that's the anhydrous ammonia, and it's people like me, it's geneticist types, plant breeder types that have been able to get those leaves up like this, and I mean, it's a wonderful thing what you can do through plant breeding. We went from 70 million acres to 90 million acres in 1 year as the consequence of the ethanol. And a subsidy of over $3 billion for this year. And then here is the other crop, the soybeans. So we say, well, but you know, there's a reality. There's an international market here, and we have to be players on the international scene. But here also you can see in April, a few years ago, a snapshot from space. Where that's brown, that's about 100% brown. Even where it's yellow and not completely brown, that's land that is open and ready for the rains to come, if they haven't already. And so here is a not unusual scene in Illinois or Indiana or Iowa. That's Iowa. So we have to ask the question, why? Why is it that we have that? And why is it that with all of this knowledge we have, that we still have this? Well, it's just the way it is, you know. It isn't just here. This is in Ethiopia. As a result of population pressure, land use getting worse, but there you can see this was not too many years before a wheat field like this right here. And there it is. So this is a global problem. Well, humans are clever. So we put in minimum till, no till. And this is given to me by a minimum till friend of mine. This picture he took. Here is milky water coming off of a conventionally tilled field. Here is non-milky water, clean-looking water coming off of a minimum till field. So, by golly, there it is right there, a side-by-side comparison. The only problem is that the water coming out of that tube has a nitrogen level 3 times the acceptable level for the Environmental Protection Agency. Annual systems leak. That's from corn and soybean fields. So at the end of the Mississippi is this dead zone, the size of New Jersey. New Jersey has to take it every time. And there's the watershed, and look how much of that watershed is part of the Louisiana Purchase. And look at how much of that watershed has the primo land-grant universities of the world. 100 of them at Iowa State alone in agronomy. So those are the places where people were trained to go off and help make the Green Revolution. We know what we're doing, gang. Look at our yields. But here's something that doesn't get paid attention to enough. Notice how much of that upper Midwest is north of the Gulf of Mexico, with the precipitation pattern right there from the south. And also notice how much of that upper Midwest was the beneficiary of the glaciers, the Ice Age, grinding those nutrients off the Canadian shield and parking them right where the rains are wonderful. Now, this is the kind of thing that forces us to feel informed. You know, when I meet somebody, I like to ask them, have you had a good glacier? You know, because if I know they've had a good glacier, I can about tell where they've come from. Not Australia. Australia's last geologic activity was 65 million years ago, and Australia is a poor country, and it's going to stay poor because it's had no geologic activity. It's not had an ice age. I mean, what kind of a country is that? You know? Now, and also, what do they got? About 22, 25 million people. So, remember back in the, you don't, in the 50s, when Khrushchev came to Iowa to be shown by Garst, Garst Seed Company man, about our corn? That was supposed to be due to the superiority of our capitalist model over their model. Well, they didn't have the same experience with the glaciers that we did either. So to bring in the geophysical reality to inform our policy decisions has really been lacking. So, a kind of a summary. The 3.45 billion year imperative, we just go after it. We've had the 5 pools. Now, there has always been an acknowledgement of nature having practical value. In the formal culture, it's in the literary and scientific tradition, and there, as Wendell Berry says, it comes in a series. Rather than the idea of nature being subdued or ignored, even though it's ricocheted through civilization, there have always been some that have said, well, let's look to nature. Let's look to nature's ecosystems. Let's look at what nature does. And so Wendell traced this back, all the way back to Job, and then he included Virgil. Before you plow an unfamiliar patch, it is well to be informed about the winds. And then he took passages out of Milton and Spencer and Shakespeare. And in Shakespeare, and As You Like It, the forest is the judge. And then Wendell then goes on to Alexander Pope, who says, consult the genius of the place in all. And then Wendell says, after Pope, the idea of nature having practical value departs from English poetry. The Romantic poets that followed looked to use nature only as a reservoir of symbols. And the next time it shows up as having practical value in the formal culture is among the scientists like Liberty Hyde Bailey, the grand old dean at Cornell. It shows up in J. Russell Smith, the tree crops. It shows up in Sir Albert Howard, and a few others. But he says that in the formal culture it goes underground, meaning in the literary and the scientific culture. But he also says that there's always been an acknowledged nature having practical value. In the common culture, it comes as a succession. In other words, a constant stream. In the formal culture, it pops up as a series. In other words, there's no continuum. You see what I mean? You got that straight? Everybody, you better have that straight or you'll get an F. Okay. Now, so here is nature in the tropics. The genius of this place is in the rainforest, water is a nemesis to fertility. There the genius is designed that to receive the precipitation and then like giant engines push it back into the atmosphere, and it helps in the regulation of the hydrological cycle of the planet. That is a perennial polyculture. Here's desert scrub. There it's designed to receive the precipitation, allocate it. It has a different genius. And across the ecological mosaic are grasslands. Here is one of our prairies of Kansas in the Flint Hills, thousands of acres that have never been plowed. there is the genius of that place, that during the Dust Bowl years, it survived, whereas the crops died. And those crops were annual monocultures versus this perennial polyculture. Those three ecosystems are real economies. There's nothing phony about those economies. They feature material recycling. They run on contemporary sunlight. So, what we're about is breeding perennial grain crops to be grown in mixtures that will allow us to bring those processes of the wild to the farm that have been denied with the annual condition. It's like clear cutting every year when you farm. So here's, we just got this new research building. I just wanted to show it off. We had a capital campaign and bake sales and so on. And here's our greenhouse. And then here on the left is wheat. On the right is a relative of wheat, and in between hybrid. We make our crosses in the greenhouse. And we paint chromosomes. So we have some chromosomes that are green from one species and they're red from another, and make hybrids and back crosses and so on. This just to show that we know what it's like to be grown-ups in science. And then here are molecular markers. That shows we're even more grown up, where we use that as a way of determining how many plants we have to plant out. It speeds up breeding. We don't do any gene splicing. That's not for grown-ups. We make a lot of crosses, and it will form an embryo, but not the endosperm. And so it'll die. Well, what we do is rescue the embryo and start it in this tube. So we rescue thousands of embryos. We're pro-life at the Land Institute. We've rescued more embryos than anybody in the whole state. So we don't have any issue. That's what we do. Then after harvest, sometimes there'll be some plants that'll send up shoots, and we say that's a perennial. Sometimes they don't, and you see there, that didn't make it, and so on. And then you plant them out, and that's the thing about these plants. They do all right in the greenhouse, but you put them out, and boy, you realize there's another world out there. And that's where you are reminded that human cleverness is not enough alone, that these things have to live outside. And so, we had 43% survive the summer out of 2,000 plants. But those become the new parents. In New South Wales, in Australia, they have some of our plants. This shows some of those that made it. And in Nepal, here's a place where their success story is. And then here, this is just to show you. Now I'm going to show you a photograph that is sure to change your life. There's no question about that. You folks will all go home different people. And here we go. I ordinarily like to hang this from somewhere, but there at the bottom, there is the plant that started civilization. That's the very species, the wheat plant. It's an annual, and you can see what a wimpy thing it is. And then here is our kernza, which is it's an intermediate wheatgrass that actually comes from the same area along the Mediterranean as the wheat. And, but this is actual size now. So imagine our prairies here in Indiana and Illinois and Iowa that had these kind of root systems, and when we came across the continent and cut it right there, That's carbon. In fact, I think the beginning of agriculture is the beginning of global warming. Because that, woo. You never know what's going to happen. Get a little more vodka here. Get it so it doesn't matter. So I was mentioning this to one group during this last day. Imagine when that plowshare cut that, what we were plowing under. And then all this carbon and the microbes that were feeding on it and that were making that prairie work, that real economy. So, I think we can safely say that the plowshare has destroyed more options for future generations than the sword. Because with the plowshare, we have lost so much of the stuff that we're made of toward the sea. So just to, I mean, I don't have anything against Isaiah. He couldn't get everything right, but thank you. And you can come up and hover over this later if you want. But the thing is, we've got to get a grip on where we are. And I need to find that little thing that I was poking around with. Who took that? Oh, thank you. Boy, thank you. So, well, here's a way to help you appreciate what plant breeders deal with. This is a yield in kilograms per hectare from 0 up to 1,600. Steve Coleman was one of our graduate fellows working with Sig Snap. This is unpublished data, but looking at an organic field of wheat and kernza. That big one is kernza and the little one is wheat. In wheat, the vegetative part is this much and the grain is that much in terms of calories. This is what we call the harvest index. A harvest index of 0.5 means that half of your total above ground is grain. And so what humans have done is select to increase the harvest index, you know, for 10,000 years. We've been doing it, and we've really accelerated it in our time. In fact, the Green Revolution wheats, you know, we lowered those wheats. We shortened the wheat plant, a good thing, because the head was bigger, and you're going to have a lodging problem. If you got a big head and then a long stem, why, it's going to lodge on you. So this ratio is important to breeders. Now, what's even more important is how much of the total biomass, how much of the net primary production is available. And here you can see that for kernza, most of this is vegetative, but up here is grain. Well, a plant breeder looks at that and says, good. This is why we are now able to say that we believe that if you want high yields, you're going to have perennials. They have a longer photosynthetic period because with your grains, your temperature of your soil has to be right, whereas the others just sort of keep coming up on their own. So there it is in the organic world. What's the matter here? Yeah. So this is the organic story. And in the situation where you have a lot of nitrogen input with a lot of input in, you know, you get even more yield. And so it's a matter of reallocating the photosynthate that is present in the vegetative to the seed. And we're actually getting, we're getting about 100 pounds per acre per selection cycle increase with the Kernza. So there's the story. I mean, what's sort of surprising there is that the organic versus the high end isn't really all that much different on the on the Kernza. Well, there's more to it than just yield, because remember the dead zone and the nitrogen that goes through. Well, here you can see in the organic system where the, wait a minute, no, here's the commercial fertilizer system. Let's draw a line right through here. This is the organic system below. Here's the commercial fertilizer. With the commercial fertilizer system, with the perennial, there is this much nitrogen that leaks, and with the annual, you see how much nitrogen is leaking. But then come down here to the organic system, and there's no leakage on the nitrogen for the perennial. So one of the species we're working on perennializing is sorghum. We do have winter hardy sorghum now, still a lot of breeding to do. This is Stan Cox, who directs our research. We've crossed this with a wild species. Actually, we doubled the chromosome number on the sorghum in order to have it compatible with the sorghum helepense, which, by the way, is Johnson grass. Hold your fire. And also sunflower, Maximilian sunflower. And in the breeding of that, the thing to do is to get what we call apical dominance and get the big central seed head instead of all those little heads. And then here's another plant we think will be good for an oilseed crop. And then we're supporting the perennialization of the upland rice in China. And here you can see some of the erosion over there where they will strip away the vegetation, clear over there in that area, and then they'll plant the upland rice for maybe 2 years and then have to abandon it. And so this is also the case in Indonesia too, by the way. So we're actually, Hu Pingyi is really doing a good job with this effort. And so here's what, finally, we're getting a little attraction out of establishment science. The National Research Council of the National Academy has said this: perennial plants reduce erosion, sequester more carbon, require less fuel, fertilizer, and pesticides to grow than their annual counterparts. So you get a statement like that. Or you get the Royal Society that says they would store more carbon, maintain better soil and water quality, manage nutrients more conservatively, and so on. So the question is, what's holding us up? What's holding us up? What else do you need? Have we not gone high enough? Maybe that's the problem. Haven't gone high enough. So, given the desecration of our ag lands worldwide and our dependency on fossil fuels, what do? Well, with perennials, the ecosystem becomes a more powerful conceptual tool. So we now come back to our slide. And here we had in 1859, Darwin gave us the first synthesis in biology. All right. In 1865, we don't have it up there, was Gregor Mendel with his work with the peas. But his work wasn't discovered until 1900. 1900 is the beginning of genetics. So geneticists were, they were working with snapdragons and chickens and Drosophila flies and corn plants and so on. they were developing a language, trying to understand chromosome behavior, giving terminology. But the people that had been in the natural history tradition, of which Darwin was a part, did not understand the language of the new biologists, the geneticists. And so there were kind of two camps that came about. But a man working in Morgan's lab at Columbia with Drosophila had grown up in the Ukraine in the natural history tradition. His name was Theodosius Dobzhansky, but he also had the lab experience with Morgan and the Drosophila flies in genetics. And he wrote a book called Genetics and the Origin of Species. And now there was another flowering in this second synthesis. Then a few years later, 1953, comes Watson and Crick that adds the molecular dimension. So there's the third. And so now we have that body of knowledge. Evolutionary biology / ecology with the modern molecular synthesis ready to go in this world with more computational power to give us the marriage of two very different disciplines. Ecology with its history of being descriptive, and agriculture with its history of being prescriptive. Ecologists had the luxury to be descriptive. Agriculturists have had the burden to be prescriptive. And those two cultures have got to come together. And that's where the generation that we now have can do it. So what do we have to help with this? Well, let's go back to the Morrill Act, the land grant colleges, the Hatch Act, the experiment station, the SmithLieber Act extension, and then let's take those three. Those are our institutions, and those institutions are pretty powerful. And then let's take what we learned out of the knowledge categories, the Enlightenment, the Haber-Bosch process. We're probably going to have some of that. And then here comes the biggie, and will probably be the hardest thing to overcome for our minds, particularly our industrial minds. Since Francis Bacon and René Descartes, we have had with us the language that goes like this: break a problem down to the point where there's no ambiguity. Well, of course, that's when it becomes totally irrelevant. Because when you break a problem down, you lose, when you, in the hierarchy of structure, let me back up a bit. This hierarchy of structure, going from atoms to molecules to cells to tissues to organs to organisms to ecosystem and the ecosphere, at every one of those levels, as you go up that hierarchy, there are emergent properties. You know what I mean by emergent property? That is, you take two gases like, hydrogen and oxygen, you put them together and you get wetness, water. That's an emergent property. So as you move up that hierarchy, you have these different properties. Now, here's where I'm criticizing the ecologists. Ecologists work with ecosystems with too much physics envy. Because what they do is look inside that ecosystem as a container and paying not enough attention to the fact that the container has emergent properties of its own. that are not as interesting. But our physics envy keeps us looking inside the container for interesting things going on. We can talk more about this, and will, I bet. But here's the point, that with our reductive approach to the world, we've looked downward to the point that the only way we have to deal with soil erosion now, or well, let's call it the top of the line way, is two molecules, Roundup and Roundup Ready. Two molecules. So we're saying if we look upward in that hierarchy to the ecosystem level, there are answers to questions we've not yet learned to ask. And we've got 100 years of accumulating data, and since 1980, with funding from the National Science Foundation, we have the long-term ecological research sites around the country, well, one's in Puerto Rico, LTERs with millions put in there, with knowledge, gathering on the shelf, unutilized largely, because it's out to understand how the world is and how the world, from the point of view of the agriculturist, how the world works. And there's two distinctions there, the isness and the works. But I'm not going to quarrel. Somebody wants one over the okay. But we've got to think about how this works, how that works. So this is probably going to be the biggest challenge, is for us to explore the great potential in ecosystem agriculture. Now, there are books on this called agroecology. Agroecology is nothing more than warmed over agronomy, dealing with annuals. You see what I mean? In other words, going back to the Greeks, you know, we've had those kind of agronomic arrangements. In our time, we say, oh, by the way, that involves an ecological principle, tight nutrient cycling. So we then call it agroecology, or we will have companion planting or do something that they've been doing for a long time. So what I'm arguing is we need ecological agriculture so that we bring the ecosystem as the conceptual tool. Now I want to say a little bit about why the ecosystem is there in that hierarchy of structure. A man by the name of Feibelman, back in about 1954 maybe, wrote a paper called The Laws of Integrative Levels. And in that paper, he developed this hierarchy of structure up to, through organisms. And he has these 12 laws. They're very general laws. Some people said, well, what comes next after organisms? Some said species, some said populations, and so on. And a man in Canada, J. Stan Rowe, University of Saskatchewan, says, well, what do those other categories have in common? They have contiguous volume. Species don't have contiguous volume. Populations don't have contiguous volume. Ecosystems do, which includes atmosphere, the soil, the organisms as a slab of space-time. So if you, he goes on to say, we have this bio-bias that then causes us to play fast and loose with the physical. Well, witness what we've done with the atmosphere, a dumping ground for CO2. It's nothing but, is what we say about the non-biological. So, and the term that I would get rid of is biosphere. It's an ecosphere. Bio shows the bio-bias and does not include, in other words, biosphere implies that there's a life support system. Well, life is a derivative of that physical interaction. In other words, the physical was here first and gave rise to the bio. So this is where we got a lot of conceptual work to do as we engage in our training. So does this have any legs? Well, there was a conference in Australia, Agriculture is a Mimic of Natural Ecosystems. We took to Washington a 50-year farm bill that was laying all this out. 3 of us did. And you know, here the 5-year farm bills, they're devoted to exports, commodities, subsidies, and so on, a little bit on soil conservation. But over here, the 50-year farm bill would have very different goals. And here's what we propose. Take the 328 million ag acres, and you'll see the brown part, those are annuals like grains, like vegetables. The yellow part are the annual grains. The green is hay or forage crops. And then that brown at the top, those are tree and vine crops. So we're saying, okay, over a 50-year period, let's double the tree and vine crops. We're saying over a 50-year period, let's double the annuals that are the vegetables. Well, we want good health. And, but instead of it being 80% annuals, 20% perennials, let's reverse that in a 50-year period. So change the nature of the subsidies, and you know, each year increase in the rotation, more perennials in the rotation. About here is when we begin to bring our perennials online, and they get more and more and more and more. Now these striped lines are to show that we're bringing in the animals for grazing, because we see grazing and fire as the primary management tools. And at the end of 50 years, we would have 80% perennials and 20% annuals. So more livestock fed on pasture, fruit and nut acreage doubled, vegetable acreage doubled, already said that. I'm going to go on here. So here's fire. This is one of the ways the prairies evolved. The grasslands evolved to invite fire. And here's our bison on our prairie there at the land. You come to the Prairie Festival, we'll give you bison meat. That's the last weekend of September. It's an intellectual hootenanny. You can camp out there. There's music, poetry, food, and speakers, and so on. But here is the domestic bovine. Now the problem, and not just the problem, but it's also a possibility, is that your bovine is a selective grazer. But if sometimes we don't want a selective grazer, we get a non-selective grazer. And I see this as an important tool. I think we're going to see more of this within this century. We'll have more of the draft animals for power. And that too is a non-selective grazer with that mowing machine. So I asked, does it have legs? I think it's beginning to get legs. The last green revolution, here were the assumptions. Low productivity is a problem. We need more yields per acre. Traditional techniques are an obstacle. Total disregard, near total disregard of the virtues of traditional techniques. Technologies are neutral. Need more fertilizer, build a fertilizer factory. Agriculture is to serve as an instrument for the advancement of industry. That too was an assumption. Agriculture is not vitally linked to wild nature. Well, those are what gave us a double, and in some cases a tripling of yields. So we're saying this is not good, this is not good, and that there's another way. So we're talking about launching the next synthesis, a 30-year mission for a sustainable green revolution, and the training of 110 PhD level scientists in 5 different cohorts, 22 per cohort. The first one would start in year 1. The second cohort would start in year 2, the third in 3, the fourth in 4, the fifth in 5. And these young PhDs be breeders, molecular geneticists, ecologists, modelers, soil scientists, plant pathologists, entomologists. And in order to train them, it's going to take almost $24 million. But then they would be assigned to different places around the planet. In Mexico, the Philippines, China, India, Africa, Uruguay. This is just a suggestion. There are other places. The reason we pick these is we know people in those places, and they've got a good track record. So that's all. I mean, I'm sure this is going to change dramatically. Here are some other examples of where they could be getting trained. So, you know, this is just a list of possibilities. But we've got them there: rice, wheat, corn, sorghum, pigeon pea, other legumes, oilseed crops, even soybeans. The perennial relatives of soybeans are so wimpy that you just wish that it never even existed. But on a site in one of those distant places, there'll be some 30 people, 10 PhDs, 10 technicians, 10 support staff, an annual budget of $4.5 million. There they are with their mission for planet Earth to move agriculture from an extractive to a renewable economy and to rescue us from the fallen world. The cost for this, the total, $1.64 billion, which is 1/3 the cost of the current subsidy for ethanol for 1 year. So this is peanuts. So let's say we're off by a factor of 5. But think of the adventure. Here we are, going through space at this huge speed. It's something like what is moving around the galaxy? I mean, it's like 600,000 miles an hour. It's fast. You know, and 60,000 miles going around, I think, the sun. I mean, we're moving. All we got to do is hang on. But what we do know is that if we were to send 100 people off on a spaceship to be going somewhere for 100 years, and the food producing system was showing trouble, the lights were blinking back in mission control, there'd be panic. There'd be real panic. What do we do? Well, we have some extra fuel on board, someone might say, that we can subsidize the food producing system, one might say. How about that, mission control? Well, you can do that. But just remember, then it's not available for, imagine the conversations. We're not having that conversation now about a system that is in as much trouble given what's happened to the soils. So there's the big picture. There's our history. Here's some of our graduate fellows that, look at them, they're ready to go. Where do they get jobs? They get jobs back in the conventional institutions doing the same old tired stuff that doesn't do anything but contribute to a resume. Well, it does a little bit more. But it's not good enough. So we have visitors. It's getting a little lift. And this institution could be one of the prime institutions for supplying those young PhDs, because we're going to the foundation world, we're going to the billionaires and saying, look, this is what you need to do, folks. And this institution could be one of those that would be contributing to that mission. So I think that that's the work of the Lord. Thank you. Yeah, I'm fine. Yeah, sure.
Dr. Jackson will entertain a couple questions. Does anyone have questions?
Yes.
You and Dr. Norman Borlaug ever talked about these ideas, and how did that conversation?
Oh, I've talked to Norman. Yeah, I've talked to him.
How'd the conversation?
Oh, you want to know about the conversation? Well, Norman is a nice man, was a nice man. I've talked with him at Summit, and I've talked to him one other time. I'm going to answer that by telling you a story. Because I was telling some other people about this. You know the story about kittens that have a blindfold put on them at birth and left there for 6 weeks? They never learned to see. Nothing wrong with their eyes, but the neural network hasn't developed as a result of the experience. So we're all blind kittens. I was raised as a Kansas River Valley Methodist. I'm in recovery. But there is Methodist in my madness. You can't get out of that, some of the evangelism that goes with it. Norman Borlaug is a product of his time. Y'all know what a widdy is? A widdy's somebody missing a shingle or two. And the widdy's walking around town one day, and he says, he sees two men digging a hole. He says, what are you doing? He says, well, we're digging a hole, can't you see? Oh, well, why are you digging a hole? Well, one of them says, it's where we're going to bury all the sons of bitches. The widdy says, who's going to cover them up? I mean, here we are. You see what I mean? I mean, people would like to get me in fights with Monsanto. But Monsanto is a version of the blind kitten, just as I'm a version of a blind kitten. And Monsanto is playing by the rules where you have corporate charters and they have a fiduciary responsibility to stockholders. The result of Dan Luton's insight. We came as a poor people to a seemingly empty land that was rich. And we built our institutions for that perception of reality. Monsanto is playing out. To expect them to not have fiduciary responsibility given their corporate charter is naive. We got a systemic problem that essentially gets rid of the kinds of benefits that allow Monsanto to live, and to see to it that the mind of Borlaug is only history. So I think Dick Lewontin went with Carl Sagan. He's at Harvard and a geneticist. Went with Carl Sagan many years ago to debate a creationist at a church-related college in Arkansas. It was a zoologist that had been trained at the University of Texas. He was a creationist. And at the end of the debate, they asked for a show of hands as to who had won. And according to the audience, the creationist won. So in the cab going back to the airport, Sagan says to Lewontin, "This is obviously a problem of education." And Lewontin says, "This is cultural and regional history." Now, what does that mean for our educational institutions? If cultural and regional history has has an advantage over education, I think we need to start coming to terms with a whole different set of underlying assumptions and go to work in some very different ways. For one, I think the universities, we need to start to force knowledge out of its categories by featuring questions that go beyond the available answers. That is, if you're asking questions that got answers, they're probably the wrong question. In our time, that's especially true, it seems. So, there's the witty with his rich insight. There's the blind kittens. There is, we came poor people to a seemingly empty land. There is the 3.45 billion year imperative. There is, you see, that's what has got to be the gestalt that gives us enough goosebumps to go beyond the awful language of the hard-headed realist, who usually uses a lot less information than what's available. So, that's my short answer. Yes?
Seems to me that part of this problem is that we have this capitalist system, and Monsanto and other companies need to keep on growing their pile of money
Right.
exponentially.
Right.
So,
Yeah, y'all hear that? The capitalist system requires growth. Well, capitalism's nothing but petri dish economics. You know, it's the psychology. See, I mean, if we look at it from the point of view of we got these num-nums here. We got the sugar. We got the accoutrements of civilization. So what we do is put in public policy because we see that some people are getting richer than other people, and that's so we can all reach the edge of the petri dish at the same time. That's justice, you see. But we need to, it seems to me, ask, what are we going to do to stop growth and go negative for a while, and then how do we stay amused while we live till we die cheap? I mean, that's really our only question, is how are we going to, I call it the mill-around theory of civilization, you know. And I don't mean doing this, because that's based on satellites, and I'm wanting to know, I'm going to figure it up too, how many acres of corn equivalent it takes to launch a satellite that allows us to do this. So let's think about that. So we got to talk about the end of growth. But just because you have, Herman Daly put it this way, let's say you have a library with finite shelf space. And if you want to add a book, you got to take one out. Now, how do you decide which to remove? You can actually improve your library as a result of limits. You know, that's possible. I mean, I'm not advocating we burn books, although I know a lot of books that ought to be burned, but I know you get in trouble if you say that. So we gotta, but this discussion about the need to end growth is happening in 10,000 places tonight all across this country, and that wasn't happening 10 years ago. Yeah.
Countries gain power by having large populations.
Right. Well, countries have power by having large populations of cars. In other words, we got to talk about the population problem. There are too many deep freezes, too many pop-up toasters in that toaster population, too many cars in the car population, too many houses in the house population, and oh yes, too many people. So, but you know, the thing about all of these populations, they all occupy space, and they're all dissipative structures. They're all subject to the second law. So, yes, too many people, but too much throughput. So I have a friend, he's dead now, he lived for 29 years in a shack 6 by 16 feet on $500 a year. And I moved that shack to the Land Institute so that people can go by there and actually look at it and see here's what somebody lived in. But he had a whole different philosophy of life. Leland was his name, and Leland said, you start doing violence to people and the environment when you seek pleasure. He said, there's nothing wrong with the experience of pleasure, but when you seek it, you start manipulating people in the world. And he also had the idea that everybody has an image of themselves that they will protect, and many of them will protect that image at the risk of violence. So he had a way of trying to deal with not having that image. Well, we got to have some image of who we are, but he was really, I think, onto an area of psychology that we're going to have to explore. So, I mean, where do we get our meaning? Is it through our resume, or through our memberships, or through what? It's going to have to be a whole different gestalt, and I think an awful lot of collectiveness. So, well, yeah.
Populations of natural power, they want the growth strategy, they want the growth economy.
Yeah.
They want the expansion of technology to stay on the cutting edge of military technology.
Yeah. Yeah, I know. We may not do it. Optimism and pessimism are really not arguments. They're opposite forms of surrender. It's what we do. And I think we're seeing a bunch of young people right in this institution, for instance. A lot of young people that got a whole different way of looking at it than what I'm comfortable with. But that's because of my neural network. Although I am thankful that my parents were born in the 1800s. 1886, 1894. So I've got an 1800s world. I was born on a farm with horses. So, but at the same time, I became a modern man. And therein is the problem, you know. But these young folk, I think, are thinking differently. They're ready. Yeah.
They like to say, be the change you want to see.
Yeah. What's that?
It's not just the young people that are saying it.
Yeah.
And I do have another question.
Oh, you got a question. Okay, I didn't see you over here.
Was this friend Leland of yours a PhD in any way?
No, he didn't even graduate from high school.
Thank you.
Yeah, but
There's a lot of other people out here
yeah,
in this world who don't have PhDs, who don't have the degrees,
yeah,
that are being ignored.
yeah. Well, that's true, and I mean, the PhD is, it's a useful thing to have. I mean, it's beyond being a passport to privilege. It also is a passport to helping one exercise responsibility in the world that we find ourselves. But we're talking about more than just the exercise of responsibility. I mean, look, I've lived in California a while, and I have visited the hippie communes because I'm interested. I've spent a fair amount of time with the counterculture. And they have a lot to say and a lot for us to pay attention to. And, you know, we can't know how this is going to come out, but what we know is it's like there's a woods, and we know there's a destination, but there's no path for us. You know, there's some suggested paths for us as we enter this. So the main thing, I think, is to have the vision, though. First of all, let's take care of our potential for food production. Take care of that. And that means saving our soils, quit treating them like dirt, save our soils as the way to save our souls. You know, that's what's on the plate. You start there, and I think that will lead to greater things. But it's an awful death to be talked to death, and senile rapture has its pleasure, but it's...
I was going to say that a good way to spend part of your time in your life is an evening listening to a visionary speaker and thinking about some novel ideas.
Yeah.
So we're grateful for your time. I just wanted to say three quick things. One is reception outside that you're all invited to. Another is, Dr. Jackson, we'd love to send you more information, a PDF of their annual report. If you're interested, you can come sign up on a piece of paper up here. And thirdly,